Hello, everyone, and welcome to Electronics Costing for PCBA and PCB. My name is Sam Ellis, and I'm an application engineer at aPriori. This product overview will consist of a 15-minute demonstration. Before we begin, a few housekeeping notes. If you have any questions after you view this demo, I will be in the live meeting room from 2 p.m. to 5 p.m. Eastern Time. Feel free to join to connect and have your questions answered. If that time block doesn't work for you, or you prefer to meet one-on-one, you can also schedule time with me via the meeting scheduler. On the event website, near the chat panel, choose People. Select my name, Sam Ellis, and schedule a meeting with me. Alternatively, you can use the Request Info button on the main showcase page to have someone reach out to you. We have uploaded a PDF of today's presentation, plus additional resources, which you can access in the Files panel. Let's begin. I've been with aPriori for about 8 months now. As an application engineer, I'm responsible for leading initial product demos and running value assessment workshops for prospective customers. I started my career in the defense industry, working on redesigns of electronic subassemblies. Before aPriori, I worked as the engineering lead at a contract manufacturer in the electronic components industry. For the demo today, I'll first cover what inputs are required. Then I'll review a couple different ways to integrate component pricing, and finally step into a live costing example for a PCB and PCBA. So what's required? For a PCBA, we just need the bill of materials file saved as a CSV. For a PCB, we extract all the relevant information from a zip folder with the Gerber files. The bill of materials file can include any number of columns relevant to your business. However, 4 columns are required. These are the level, customer part number, the quantity of each component, and the manufacturer part number. For the PCB, we have initial support for Gerber RS-274X format with Exelon format drill files. We currently support Allegro, PADS, and Altium Designer for ECAD packages. aPriori partnered with Silicon Expert to offer integrated component lookup. The bill of materials is loaded into a web application called Electronics Data Collection. Each component is reviewed for price and other manufacturing information, such as mount type and availability. The other option is a component library within aPriori. If you have component information stored in an ERP system, this can be imported into the library. There are some necessary columns, but more can be added to support your use case. The demonstration today will cover the BeagleBone Black wireless board. It has a mix of plated through-hole and surface mount components with surface mount on both sides. Let's dive into the software. To start analyzing a PCB, I just need to navigate to a zip folder which contains all of the Gerber files for my board. Once open in aPriori, it will automatically assign the PCB process group. I'll leave the XSLT mapping file as default, and then I need to specify the digital factory, or where in the world am I going to manufacture this board. Based on my selection, it will impact information such as labor rates, overhead rates, and SG&A. I'll set this as USA default for now. Finally, I just need to input what the production run of this board looks like. Let's say I'm going to manufacture 1,000 boards in a year in batches of 250. Then I can run the manufacturing analysis, and we can see that aPriori parses this board very quickly. I like to start in the part summary tab, which gives me a nice bucketed breakdown of relevant high-level information. Looking at the cost by category percentage breakdown, I can see that overhead is the largest cost contributor. The cost by process percentage breakdown gets into the individual manufacturing processes necessary to manufacture this board. I can filter based on percentage contribution and see that drill circuit holes and copper plate are the largest cost contributors for this board. I can also review overall material information such as the stock panel size and utilization percentage. If I want to review utilization in more detail, I can head over to the material nesting, which will show me the pattern of boards on the overall panel size. In this case, I have array depanelization checked off, which means that after manufacturing, these boards will be cut out into the 4 segments seen here to then be provided to the assembly line in arrays of 2x3. So how does aPriori start to generate all of this rich manufacturing detail? It begins with the geometric cost drivers, which are extracted from that Gerber file. So the most basic is the layer GCD, which there will be one for each layer in the board. In this case, it's just a 2-layer board, so I have 2 layers. The other main GCD is the common hole group GCD, which there will be one for each set of holes sharing the same diameter, tool number, and start and end layer. Based on whatever common hole group I select down here, we can see that it highlights all of the associated holes in the graphics window up top. Also, on the pane to the right will give me the details for that common hole group. If I expand out this line item, I can determine which layer the holes start and end on. I can also review details about the material stock. Heading over underneath manufacturing process, right-clicking that line item allows me to open up the process setup options, which shows me all of the information as well as allowing me to edit to align with my current board configuration. In this case, since it's just a 2-layer board, aPriori assumes a 2-ply board configuration. It will optimize my panel size based on the production run, and I can see I have configuration options for part nesting, core insulation type, and glass transition temperature. aPriori will also give me a computed board thickness and the information that went into that computation. And if I scroll down, I can review and refine information about nesting the boards and if I want to enable array depanelization or not. So let's take a look at the manufacturing process. aPriori is going to build out a process routing based on the information extracted from the Gerber files, as well as the machines available in the digital factory. We start with material stock, drill the registration holes, and then enter into a number of layer processing cycles based on the complexity of the board. In this case, I just have a 2-ply FR4 board, so I have 1 layer processing cycle. If I had a more complex board, which had holes starting and ending on intermittent layers, that's going to require multiple layer processing cycles. aPriori will automatically detect that information from the Gerber file and apply the correct number of cycles. After that process is complete, we're going to apply solder mask, add in any surface finish. In this case, I have hot air solder leveling added, silk screen, depanel, and then any testing required. We have flying probe and automated vision out of the box as standard, but you can add in any additional tests as required for your normal processes. Now let's head up and review the part details. This is going to show me that same process routing breakdown that we saw below, but it's going to allow me to dive into each of the individual manufacturing times for each of those processes. So for example, drill circuit holes is taking 91 seconds of cycle time. I can right-click on this cell and show formula dependencies to determine how aPriori is calculating this number. I'll expand out this calculation to show just how much goes into each of these calculations, and know that any of these values can be configured to align with your capabilities, a supplier's capabilities, and you can even edit these numbers on the fly to begin that fact-based negotiation. Now the cost summary tab is going to give you that full roll-up of all of that information that we just covered. So my fully burdened cost is going to be that entire makeup of my variable costs, period costs, and capital costs. In this case, $6.64. To show how quickly aPriori can adjust the analysis, let's change one of the processes. So maybe instead of hot air solder leveling, I want to add an ENIG finish. So once I select this, hit OK, aPriori will update that process routing and apply that new price based on that adjustment. So we can see here that the fully burdened cost increased from $6.64 to $8.04. And I can do the same thing with a machine too. So on my drill circuit holes, let's say maybe my supplier doesn't have this machine, I can adjust that machine and say, maybe let's select the VIA mechanics here. Again, it's going to rerun that analysis and adjust my cost accordingly. With just 2 changes, the price of my board increased by almost 50%. It's extremely important for both design engineers and sourcing professionals to understand how adjustments and machine changes can impact the final product cost. Now let's analyze a circuit board assembly. As I mentioned in the introduction, a PCBA requires a bill of materials file which contains the level, quantity, part number, and manufacturer part number for each component. Once I have this information supplied, I head over to electronics data collection, which is a service that ties in with Silicon Expert in the background to discover information about the components. I'll open up my BOM file and upload. Silicon Expert is going to parse through each line item in my bill of materials file and report back information that it found on these components. You'll see once it completes, I have green check marks and yellow exclamation points. If I click on a component with a green check mark, that means it had a match and it's all good. It found the average cost, minimum cost, mount type, pin count, and availability. These are just a small subset of the information available from Silicon Expert, and this can be tailored to whatever information you need to report. If I filter by parts that have an action needed, these are items which Silicon Expert found, but did not find all the required information. So for example, this component is missing average cost, pin count, and has an obsolete availability. So this is really good during the early design phase to quickly identify components which have some sort of issue and make me ask myself, can I design this out, or do I have a way to purchase enough of these components to survive the lifetime of my production run? So once we have all this information, we download the exported bill of materials, and that will become our starting point for costing the PCBA. Back in the software, I click the PCBA macro button to begin the manufacturing analysis. I'll navigate to my bill of materials file, open it, and then specify my part number and scenario name. The component import behavior defines where I'm receiving this information from. If you remember back from the introduction, I can get this from either electronics data collection or an integrated component library within aPriori itself. In this case, I'm going to prefer the lowest cost between those two sources, and then for physical information such as pin count and mount type, I'm going to prefer the information that I extracted from electronics data collection. The production settings are going to be just like what we saw for PCB, so I'm going to select that same generic USA factory, and we're going to do an annual volume of 1,000 in batches of 250. I'll add in my board dimensions, as well as it is a surface mount double-sided board and plated through hole single-sided. Then let's say we have about 30% of the components on the bottom side. Again, back to the PCB, I have an array of boards here that I'm supplying to the assembly line, so I specify that information here, and let's say that I'm doing an automated depanelization. Now I specify any secondary processes that I'm going to apply to this circuit board. So for this case, let's say I'm going to do 2 marking labels. I'm going to add in an AOI for the top and bottom, and then I'll specify a machine spray conformal coat. These are the testing and special processes that we have out of the box. You can add and configure any of these to align with your needs. Once I'm set, I click OK and OK, and aPriori is going to step through each of those components in the bill of materials and build out that full process routing to determine how to assemble this board. The assembly tracker will give me a nice graphical view of where my assembly costs are coming from. In this case, I have about 76% from the components themselves, with the balance due to the actual assembly of the board. It also gives me a status of my components. So if you remember, when I exported that information from EDC, I didn't really correct any of those errors, and that's what's being reported here in the uncosted section. I also have a summary of component costs, a breakdown between material, other direct, and SG&A. Other direct and SG&A are going to be impacted based on that digital factory that you select. If I review assembly details, I can see that the status for components that have an error are red here. So I went back to my bill of materials file and added in the missing information. When I reran the analysis, you can now see that I have 100% of components successfully costed. Now let's take a look at the manufacturing process. aPriori is going to put together that full process routing required to assemble these boards. Starting with typical prep processes, such as kitting and PCB prep, we're then going to get into the surface mount double-sided assembly line. So starting with the first side, we're going to have all our standard operations. We're going to flip the board and do the same thing on the second side. And then we're going to get into the plated through hole components. In this case, I just have it set to hand install, and this supplier has a selective solder machine, and then we're going to do a standard visual inspection after that. And then any sort of special processing that I selected from that initial window will show up at the bottom here. In this case, we just have depanelization and conformal coat. Now let's switch back over to the Assembly Details tab to take a look at the cycle time information for each of these processes. For the surface mount components, we're using a Juki medium volume, medium mix machine. On the top side, aPriori is saying that it's going to take 22 seconds of cycle time to place these components. So again, let's take a look at the formula dependencies to see where this number is coming from. We expand it out, and all of this information is stored in the selected machine. So it's going to give me my chip, fine pitch, and IC placement times, and based on whatever machine you select, that's going to pull in a different number. So, your cycle time could be faster or slower, obviously, depending on what machine you're using. Finally, let's take a look at the cost summary tab. Just like on PCB, this is going to give me that full breakout rolled up into that fully burdened cost. In this case, it's an assembly. I have a fully burdened cost of the subcomponents at $75, with the balance being the actual cost to assemble the board. I also have some capital investments. Here it's for programming the machines. Let's do another trade-off study. Say my supplier comes back to me and says, well, we don't actually have a selective solder machine. So instead of selective solder, let's do wave solder instead. I'm going to go into my routing selection, navigate to the plated through-hole install, and I'm going to exclude selective solder and include wave solder. So let's hit OK and see how this impacts the price. Pull this bar down, and we can see that my fully burdened cost increased about $1.30. So this is how you can start to open up that conversation with your suppliers and really get into the details of where the costs are coming from. Do the numbers align well? And, does everything making sense as is? The depth of information available in the electronics cost models can be used to drive efficiency, consistency, and transparency of cost across different business units and even within the same business unit. One customer is using aPriori as part of a strategic global initiative to help meet target costs, conduct trade-off studies, and assist in costing of competitive teardown projects. With the software, they're able to get results 96 times faster for PCBA costing than their previous method. Thank you for watching this demonstration. If you have any questions at this time, please feel free to join the live meeting within this booth. You can also navigate back to the main product demo page to download additional resources on this topic, view other demonstrations, and schedule a time to meet with me one-on-one. Thank you and have a great day.